How's it? Hang loose, hang loose. Okay. With all the kind of channels I got, well, one channel with all kinds of series. Hang loose, mongoose. Welcome, new subscribers. Yes, I have very different series. You got the Spook 101 for supernatural stuff. Newspaper Hawaii, which you see, I make fun, kind of glib with the news, but try to put out information there. And some Shakespeare, which I'm going to do reading off of Zoom. And Science Break. I forgot about Science Break. So we're going to do a Science Break right now. I was looking at my stuff going, I was thinking about this. I was sending my sister an email. My sister in Wamanalo likes the science and the conspiracy theories. And I got to make this video. One, it's about the asteroid. And I thought it came and went, but it's actually tomorrow, which would be today. So the asteroid, the killer asteroid, the planet killer is going to happen tomorrow. But how much of a planet killer is it? That's why Science Break. Now, I'm not out to promote anything but cryptocurrency. That's the cryptocurrency wallet. Oh yeah, don't forget Crypto Corner. That's popular because people like crypto. So, what about this asteroid? Well, I got my computer up, and we're taking a look at this website that, okay, my sister, yeah, she likes the kind theories, and she's like, you gotta see this movie Greenland. So I watched the movie. At first it was horrible audio, but a lot of the story. I was watching it, and the movie is portraying a large asteroid comet hitting the Earth. And of course it goes into that doomsday scenario and people scrambling about. The man and the woman, troubled marriage, they have this kid, has a medical thing, but he gets selected out of all these people to go into this underground bunker by the government because, you know, he's a civil engineer and they need civil engineers for the, I guess, repopulation of the planet after it gets whacked. So that's okay. That's the movie in general. It's an okay movie, but it is a scathing review because I was just and I was good at scathing. I gave it quite a scathing, once over, more 50 times over. But I missed the point. My sister was pointing out that there's a real asteroid going to be zipping by Earth very close today. Yes, sirree. And I mentioned conspiracy theories because there's all kinds of stuff like that. And we'll get into some of that stuff too to see fact versus fluff. Just like I'm doing the Exorcist stuff. Where's the fact? Where's the fluff? Do I need to be scared at all? So in this one, at first she says, she emails, you made light of it and mentioned the word conspiracy theory and chose not to pass on the info and the Neo from the Matrix. Neo. It's a near Earth object, which could be a big giant rock, huge. You forgot to pass on that info on the Neo site, which lists all the incoming, and they are tracking for months in advance. It's NASA, so it's real science. Real science by real scientists. Because that's the thing I'm going to do with my sister. Hopefully, get a chance. Send a comment. Say, yeah, man. Hey, sis. Because we'll look at stuff like conspiracy theory and try to have a debate, like the pro and con. Try to get down to the real parts of it, if there are real parts, versus the hype, which you see so much of. Did you know the word conspiracy theory is introduced by the CIA so the sheep will be embarrassed to be labeled as such and not talk about classified subjects? A theory is a theory. If it has facts, it's supported theory. Evolution is a theory, but it's heavily supported by the fossil record. It's not just someone's opinion. And a conspiracy is just, for me, by definition, more than one person, right, Becky, who's conspiring. They're conspired over it. I had this on, Bucky. Come on, Bucky, put on your headphones, because there's gonna be a big boom. Oh, hide in your bunker, you damn idiot. We're all gonna die. I don't know. So we look at the conspiracy. Don't listen. Don't listen to them. They're crazy. So, conspiracy theory is just like a bucket of stuff nowadays, and people say you're crazy, and I don't want to hear it. And there's a point behind this. So, in light of all that, let's look at Give Science Break, and give science a break on Science Break, and let's look at the real stuff. Okay, so here's that website. Oh, wrong. Okay, can't open this page. Why? What the heck happened? Oh, there it is. I know why. Oh, snap. Oh, come on. There's a great line in the movie. The guy's frantically trying to make a phone call, and he can't get through. It's all this. And he's like, just has this little house cordless. He goes, "Why doesn't technology work when you need it?" Great line in the movie. It's my favorite line. But, I won't talk about that much, except it's a big disaster movie, and they're trying to do it very realistically with special effects. So if you enjoy that, the movie is Greenland. And I won't go anymore in case you want to watch it. I'll be spoiler alert guy. What about the real asteroid? Let's check out NASA. NASA site. Link I'll leave in the description. And my welcome new subscribers. This is just one of the series, one of the channels in my channel. So this is Science Break. Okay. NEO, not the Matrix, but near Earth objects, close approach. So here's this C.N.E.O.S, Center for Near Earth Objects Studies. So they study it. It's off the Jet Propulsion Laboratory, NASA stuff, California Institute of Technology. This is their site. There's a brief tutorial to tell you how to navigate and look at this site. So that's cool. And I watched it, and it's pretty neat. And two things I picked up out of the tutorial is astronomical units, okay? Which is basically not astrology. That's like Capricorn and Taurus and all those lovely little creatures in the sky constellations. But this is astrology. I mean, astronomy. See, I get those mixed up, but you don't have to. Astrology is the stuff, and astronomy is the telescopes and Galileo. And water. Hot days, stay hydrated. So, in this one, they track these things, and they give the object's name, because there's so many, they got alphanumeric names. Otherwise they'd run out of George and Betty and Sue and all that stuff. They already ran out of names for hurricanes, so they're running down the Greek alphabet. Good God, it's almost today. See, I'm starting to film this. I'm filming this in September 25th. In 1 minute, it'll be September 26th, the day of the planet killer. Or is it? So we're looking at these objects on the Jet Propulsion NASA site here. And I'm trying to keep time here. So here's the object right here. And I looked at this chart after watching the tutorial, and I noticed these units here. And here's this one that has like a smaller unit, 0.91, 0.92, and I'm like, well, I guess that's it. That's a close one, because these are distance from the Earth. So, quick tutorial. We'll do this. I don't know. Okay. Let's see if we're gonna. Okay. Here's the sun. Gives off light during the day. Here's the sun. Here's the Earth, because we only have so much time on Earth. The distance between the Earth and the sun is 1 AU. That's a solar whatever. The distance between the solar, or sun, and Earth. That distance is 1 AU unit. And it actually comes out to be 93 million miles, or 150 million kilometers if you like metrics. But here's another one that's a little more interesting, and we can deal with that thing later. So, in my lens cap. Okay, here's the Earth again. Time is ticking. Dorothy, I'll get you, my little pretty. Here come the sands of time. And here's the moon. Okay, so Earth, moon. The distance between the Earth and the moon is a distance, d, and it's lunar because it's moon. So LD, lunar distance. So that's an easier one. So we'll use the LD, lunar distance. And those are only 1 LD is 238,803 miles, or if you like kilometers, 384,317 kilometers. So if you multiply this, there's two charts here, two columns here, and they're LD distances, or AU, in case you want to multiply millions and millions instead of 100,000s. I suggest LD. So you just grab yourself your little friggin' Texas Instruments, the only thing that came out of Texas that I freaking like, except for my good friend, God rest her soul. Yeah, just grab yourself, 0.91 times LD miles, 238,000 ring. And that basically came out to be 217,310.73 miles. 9/10 of the distance to the moon. So, it's not going to hit us. Spoiler alert. If it did, we would be in some deep kimchi. And allow me to explain. First off, we'll do this. Physics. Force equals ma. A would be acceleration. This is going to be a big number because this thing's going to be accelerating like frickin' faster than 10,000 cannonballs. I mean, fast. Speeding bullet, faster than Superman. This is, I don't even know. Mass. This is where it's going to make all the difference. They just multiply those two and you get the force in newtons. So if you have a bigger mass, you're going to have a bigger force. And that's the bottom line. That's called physics, me hearties. Yes. My passwords in this thing. Why does it do that? Crazy me. So, I'm sorry I'm leaning over because this is take 2. My take 1. I'm redoing this. This is take 2. Can you believe it? I did a take 2. My first take, I zoomed in my lens to focus and I left it zoomed in, so you would have seen this much of my face. It would have been like this. And then let me tell you about the lunar distance. So I was like, oh my god. So anyways, okay. What do we have? The mass, right? Which is how many atoms are basically making up the chunk. This has the same mass on Earth. If you go to the moon, it will have the same mass. It's made out of the same amount of stuff. Atoms, same amount of stuff. Gravity on Earth is bigger. This weighs more on Earth. You go to the moon, less gravity, it weighs 1/16. So the weight is different, but the mass is the same. Thinking back at my own physics professor. So, if you had a massive object like this meteorite, it's a meteor until it hits the Earth, then it's a meteorite. And this is actually just a lava rock. If this was a meteorite, I'd be rich. So, yeah, it's a meteorite. Want to buy it? No. This is basalt. It's lava rock, a very dense, dark basalt. And it's been smoothed over by water. It looks really cool, so I saved the rock. If this was a meteorite, I don't even have it. I have these little props. Dang it! Oh, there it is. This is a compass, a cheapy little compass. Now, if this was a real meteorite, it'd be made out of mostly iron. Iron. That's right. Not steel. Iron. Iron. Pure iron almost. Most meteorites are. Going through the fast, these things melt. So it rearranges all the atoms and that friction and that melting, so it's all aligned. So at times the meteorites hit the Earth, it becomes a meteorite. Right? It's magnetized. If this was a real meteorite, this compass would be flippin' ape. Yeah, but it isn't. So, just to show you something, and also that was fun to do. What is the size? Let's look at this thing. Wait, let's look at this thing. What do we got here? I have to watch this time because I have a limited amount of time. So we're going to do a little time warp reel change. 1, 2, 3. Okay, I hope that was smooth. Just reel change there. Okay. So where are we? Where was I? Those time warps, they rearrange the molecules of my mind. And oh yeah. Whew, okay. Force equals ma. So the mass of the meteorite or asteroid when it's up there. But if it starts getting close, we're in trouble. Okay. The mass of this thing, they calculate, noticing this website, 4.5 meters to 10 meters. Each meter, approximately 3 feet. So, they said it was the size of a bus. And not only it was the size of a bus, it was likely to burn up if it entered the atmosphere. Likely. So, what are we talking about? Yeah. Say, this is the asteroid. Ah! Ugh. This is heavier than the other one. It's backing up. So, if this was the asteroid, 5 meters, 5 times 6, you get 30 feet, about the size of a bus. Now, if you look at it like, okay, here we go. Read this little guy. This is 10, 20, 30. Here's the size of a person if he was 10 feet tall. Sometimes I feel 10 feet tall. So, well, my point is, see a little shaka sign there. Shaka. So, my point is, this ain't gonna happen. Oh no! Oh no! There we go. I wasn't paying attention to my sister in Wamanalo when I got hit flattened by the asteroid. Ow! Son of a bitch. Damn home projects and if I can make this entertaining. God forbid I make ones for killed children. children. Oh my god. All right, so that's still a pretty big size rock, and if that hit the ocean, it would displace, especially FMA. It would displace a lot of water, not because this is the amount of water it's going to displace. This is rocketing through. You know, it's just, it would punch a giant hole in the ocean with the water, and that much displacement of water, you would have a tsunami unknown to humankind, never ever seen in person. I mean, 1,000-foot high, it's probably small estimation. It would be, and then what it did to the atmosphere, who knows? Because that's the killer. The asteroid, if it hits, is the atmosphere. Now, I was going, hey, you know what? What about this? You know, it ain't gonna heat and stuff like that. So we look at this stuff from, you look at this website, it's really kind of cool. Now we're gonna look at this. It's named SQ4. What a lovely name. And here's all the stats on SQ4. And the wonderful little thing about this is you can play with, where is it? The orbit diagram. So it shows you a diagram of the orbit. Why not? And this is a cool diagram. You can zoom in and zoom out. Look how far away those planets are. Uranus is very far away. Makes me sad. There's Saturn, Jupiter. You go on in. And then there's a close cluster. Mars, the asteroid belt, then Earth, Venus, Mercury, Sun, and that white one, that white elliptical, is SQ4. Now what's kind of fun about this is you can have this sucker, you can zoom in and zoom out and play with it, la 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 la, and if you click and do the same thing, you can tilt this thing. Oh yeah, oh yeah, that's right, baby. And then zoom in. Now look at that stuff. See, my sister was right. She knows the stuff. Now if you go over here, you can play this animation. So that white thing going by, and there's on the blue ellipse is Earth. And notice it crosses Earth's path right there. That's right. This isn't like that scary. But it was doing this ellipse, and that white path crossed right over Earth. And I even did this thing where I was like moving this thing. Well, that's close. You tilt it, and it really was overlapping Earth. That's the orbit, but those little dots are all the same, so don't be confused, because some are bigger and some are smaller. So when that went like that, like wait a minute, it's far away, right? So I can understand where people get like upset. So what is this? What is the one? You know, this dinosaur stuff. Okay, let's do a comparison, right? How big was the dinosaur asteroid? Okay. At the end of the Cretaceous, okay, there's the Triassic, there's the Jurassic, you have Allosaur, and there's no T-Rexes until the Cretaceous. So Jurassic Park got that part wrong. In the Cretaceous, there's T-Rexes. At the end of the Cretaceous, asteroid, poof, it messed up the atmosphere, and just about everything almost was extinct. Not complete, but like 70 whatever percent. The extinction event. After that's the Permian. So that's the PK, Permian Cretaceous. Hard C, K. PK boundary. And then mammals. What's this asteroid that nailed the dinos? Well, right off the coast of the Yucatan Peninsula, you know, Chichen Itza, if you ever see those pyramids, the Yucatan Peninsula, it's off of Mexico, below Florida, is the chicks you love. All the chicks I've loved before, all the chicks you love. So now you won't forget the name. It's Chick X, which is actually Chicks You Love. Lub-a-dub-dub. Chicks You Love. It's Chicxulub Crater. It's half in the ocean, half in the Yucatan Peninsula. Now this thing is a big thing. They figured this is the crater left over by the asteroid that hit dinosaurs. How big was this asteroid or comet? 11 to 81 kilometers, or 6.8 to 50 miles in diameter. $60 feet, 6.8 to 50 miles. Quite a difference. That one didn't burn up in the atmosphere. So now when we look back at this one, and we're looking at this animation, and oh my gosh, it's getting close. Let's see, one of these things that overlaps, and it's really kind of spooky. Doesn't there. But anyways, so the planet killer this time is not going to be a planet killer, but it's very fascinating that it's going to fly by Australia, down under somewhere. And if we look at the time, it's the 18th hour of, I don't know, whatever the, I don't know what, I guess that's universal time. So calculate that out. The 18th hour at night. It's the 18th hour of the day, so Greenwich time, and then 18 hours later, I don't know, whatever time that is. But I wouldn't worry about it. But that's a little science break, and kudos to my sister and for passing out this Jet Propulsion Laboratory asteroid tracker, so you too can calculate asteroids and not be in fear, or be in fear. Up to you, whatever. I'm just saying, hang loose, Australia. Wait a minute. We can't end like that. We just can't. Siri, tell me you're an asteroid.
I'm not sure I understand.
You wouldn't, would you? Are you Australian?
I come from a long line of code.
I guess that's code for Australian. Anyways, hang loose, aloha.